Hey guys, I hope everyone had a great weekend and that you all have a great week. So today's practice problems, we're using the same slide deck as last week, but we are starting on slide 24. So the first thing you'll notice is a Math Antics video. So as you start solving problems, if you need a little extra review, come back and watch this video that is on slide 24 of your slide deck today. So division is the inverse of multiplication. To solve an equation that contains multiplication, you're going to use division to undo the multiplication. So remember, 4m actually means 4 times m. This is multiplication. So if you have 4 times m is equal to 32, just like last week, we do the inverse operation. So the inverse of multiplying by 4 is you're going to divide both sides by 4. So 4 divided by 4 is 1, and 1 times m is m. And on the right side of the equal sign, 32 divided by 4 is 8. So that is our solution. For equations, you can check your answers. So if you substitute 8 for m, does 4 times 8 equal 32? Is that correct? It is. So we know m equals 8 is the right solution. All right, so here we have another equation, 5p equals 75. So what's happening to our variable p is being multiplied by 5. So we're going to do the opposite operation. We're going to divide both sides by 5. 5 divided by 5 is 1. 1 times p is p. And 75 divided by 5. 5 goes in 7 once. 5 goes in 25 5 times, so P is equal to 15. If you plug it in, double check your answer. Does 5 times 15 equal 75? It sure does. So our answer is correct. All right, so always make sure you find that variable and then see what's being done to it. So R is being multiplied by 8. Once again, the opposite or the inverse operation of multiplication is division. You're going to divide both sides of the equal sign by 8. 8 divided by 8 is 1, and 1 times r is r. And 16 divided by 8 is 2. So the solution is r equals 2. Okie dokie. So find your variable. X, what is happening to x? X is being divided by 7. So now the inverse operation of division is multiplication. So we're going to multiply both sides of the equal sign by 7. So 7 times x over 7. Those 7s will cancel each other out, right? You can cross simplify. So 1 times x is x, and 5 times 7 is 35. Our solution is 35. If we're going to check our answer, we're going to substitute 35 for x. Does 35 divided by 7 equal 5? Yes, we know it does. So we know our solution is correct. All right, our p is on the right side of the equal sign, our variable is, and what is happening to it? It's being divided by 6. So we're going to do the inverse operation, which is to multiply by 6. So 6 over 1 times p over 6. The 6's will cancel each other out. 6 divided by 6 is 1. 1 times p is p. And then we're going to multiply 13 times 6, which is 78. Our solution is 78. You can always check your answer. Does 78 divided by 6 equal 13? Is that correct? Yes. So we know our answer is correct. Oop, I couldn't find my mouse. There it is. All right, so here's our variable letter J. What is happening to letter J? It's being multiplied by 3/5. So what is the opposite of multiplying by 3/5? We're going to divide by 3/5. Divided by 3/5. So 3/5 divided by 3/5 is 1. All right, so don't forget, how do you divide fractions? You're going to keep it, change it, flip it. So this is our math problem now. So we can cross simplify. Actually, 25 and 3 don't have any common factors. So we're going to multiply straight across. So 25 times 5 is 125, and 3 times 1 is 3. So how many times will 3 go into 125? So 4 times 3 is 12. Bring down the 5. 3 will go into 5 once with 2 left over. So J is going to be equal to 41. Remember that remainder comes up here as our numerator. 41 and 2/3. 41 and 2/3. So basically, to get rid of times 3/5, you're going to actually multiply by its reciprocal, which is what we did right here. To get rid of 3/5, we're going to multiply by its reciprocal, which is 5/3. And our final answer is 41.6, repeating, or 41 and 2/3. 41 and 2/3. All right, so solving equations in one step. Make sure you realize that the inverse operation of addition is subtraction. And here's an example of solving by subtracting. The inverse operation of subtraction is addition. And here's an equation that's being solved by addition. The inverse operation of multiplication is division. So this equation is being solved by division. And the last example is the inverse operation of division is multiplication. So this equation is being solved by multiplication. All right, so I want you guys to pause the video and I want you to try each of these math problems and then watch the video to check your answers. All right, so on the first one, hopefully you guys added 12 to both sides. And you should have got 35. X equals 35. Number 2, to solve, you have to divide by 4, which is the opposite of multiplying by 4. Our 4's go away, and x is equal to 5. Number 3, we're getting rid of a positive 22. The only way to do that is to subtract 22. So we should have 25. All right, number 4, we're getting rid of positive 3. The only way to do that is to subtract 3, and x is equal to 11. Number 5, we have k divided by 9. What's the opposite of dividing by 9? We're going to multiply by 9. Multiply by 9. These will cancel because they're inverse operations. So 6 times 9 is 54. Number 6, k divided by 21. The opposite of that is to multiply by 21. So our 21s will cancel. K is equal to, what would that be, 147? Number 7, how do you get rid of minus 8? You would add 8 to both sides. So y is equal to 39. And then number 8, the opposite of times 13.5, we're going to divide by 13.5. And what is our variable equal to? That would be 4. So x is equal to 4. So how'd you guys do on those? I bet you got them all right. All right, so we're going to move on now and talk about how to write equations from word problems. So you guys need to read over this here at the top and then look at each of these examples. A number increased by 9. So we practiced writing algebraic expressions. Now we're going to write algebraic equations because we're going to add equal signs. So the words that's going to represent our equal signs is always going to be either is or is equal to. So a number increased by 9 is or equals 15. So look at each of these examples. I want you to read these situations at the bottom. Look at the equation and make sure you understand how these equations are written based on the word problems. All right, this is a video. It's kind of entertaining. I encourage you guys to watch that. You will enjoy it. All right, so just a reminder, these are words that we've already talked about this year. So you should be familiar with each of these columns. All right, here's another grid video. It's 12 minutes long. So all of these go over how to write expressions. And of course, expressions don't have equal signs, equations do. All right, so let's look at some of these examples. Here's 5. So I want you guys to pause the video and I want you to come up with your own equations and then come back to the video and make sure you get them right. All right, so the first one is actually an expression, 3 times a number. So just a reminder, we would write that like this. Of course, your variable could be any letter in the alphabet. Number 2 is an equation because I see the word is. 5 times a number, so 5 times a number is 30. So that's what our equation would look like. 3 less than a number. So hopefully you guys remember less than is one that has reverse order. So you're actually going to start with your variable and then subtract 3 from it. So don't forget that when you're doing your practice problems this week, make sure you have these in the right order. 7 less than a number, 7 less than a number. Now here is what it equals, right? So 7 less than a number is 20. A number divided by 3, so a number divided by 3 is 21. You can write it like this, or you could write it out horizontally. Both of those are correct. They mean exactly the same thing. How do you feel about those? All right, so you guys need to take the time to read these examples as well. Oh, I think it's the same examples that we looked at earlier. Yes. All right, so see if you guys can come up with an equation based on these scenarios. Sarah used a gift card to buy $47 worth of food. She has $18 left on her gift card. How much money was on her gift card? All right, so a lot of kids have hard time. You know how to solve the problem, but our goal here is to actually write the equation. So how much money was left on our gift card? That is how much was it worth to begin with? That's our variable. That's what our variable represents. So we don't know how much she had originally, so that's going to be our variable. We do know that she bought $47 worth of food, right? So whatever the total was, she subtracted $47 from it, and what was left? 18. Okay, so this is the equation we're looking for right here. And then, of course, to solve the equation, you would add 47 to 18. But I really want you guys to practice writing the equation. A taxi charges a flat rate of $3 plus an additional $1.50 per mile. All right, so we don't know how much money was spent on the taxi. So this isn't an equation, but it's going to be an expression, right? So how much are we going to be charged? Well, we don't know the total, but we do know that they were going to charge us $3 just for getting in the taxi plus $1.50 per miles. We don't know how many miles this person is taking. So our X is going to be the number of miles. So 1.5 times X plus 3 is going to be our expression. Now, if it said, George spent $27 on his taxi, and then this was how we find out how he was being charged. We could turn this into an equation by setting this equal to 27. But they didn't give us more information than that. All right, the next one, Tina wants to sell 30 items for a fundraiser. She knows she has 5 days left to sell. Write an equation to find out how many items she must sell per day to reach her goal. So could you come up with the equation? So she's going to sell 5 days, 5 days times the number of items per day for a total of $30. So this is the equation that would go with this situation. And of course, we know that's 6 items per day, right? George and his 2 friends each purchased popcorn at the movies. Each popcorn cost $6.25. What was the total amount spent on popcorn? So how would we get the price? We would multiply 6.25 times 2. Oh, his 2 friends. So we would multiply 6.25 times 3. And what was the amount? We don't know the total amount, so that would be represented by our variable. All right, so here's just some final questions to challenge you guys. See if you can go through and answer each of these. Solve these on your own and see if you can write a verbal equation for each of these scenarios here, each of these word problems. These math equations. All right, you guys, I hope everyone has a good day, a great week. And if you have any questions with any of your assignments this week, please let me know. Everyone have a great day.